we are working through dot products. I'm going to do some more questions involving finding the angle between two vectors. I think for the most part, these questions are plug and chug, aren't they? You just find the bits and then you do inverse cosine. Couple of the rules of the game, see if anybody was paying attention yesterday. When you're doing on your calculator, what is probably the first thing you should check?
Radians or degrees?
Yeah, radians or degrees. Now that I've said that, degrees. Well, we work on the assumption, I'm sure I've said this, but unless the book specifically says otherwise, everything is degrees, right? So if they say, what's this angle? 42 degrees is where you go. I think the other one's harder to describe, but didn't we go through all the weird ways in which you cannot do this correctly? So it's really brackets, 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 right? Almost brackets everywhere. Okay, so let me pick a question right off the bat. You can never find ones when you want them. Oh, probably down here. Okay, I'll just make them on. We want to know the angle between 1, 0, and -2, and the vector v, which is 3, 1, 5. So if you're being asked to just simply find the angle between two vectors, you find the dot product and the lengths separately. So in this case, 1 times 3 plus 0 times 1 plus -2 times 5. And what's that get you? 3, add 0, take away 10. That gets you -7. Don't I know that theta is going to be bigger than 90? Just by that. Right. If a dot product is negative, you're going to have an angle somewhere between 90 and 180 degrees, guaranteed. If it had been 0, wouldn't I know the answer is 90 degrees, write it down and move on to the next question. I don't need to do extra work. But got a little bubble, you remind myself. The magnitude of u then is 1 squared, nothing squared, and a -2 squared, which I get to be the square root of 5. And the magnitude of v, 3 squared, 1 squared, and 5 squared, which is the square root of 35. Right, we're ready now. The cosine of theta is the dot product over the length of u times the length of v, the magnitude, I guess I should call it, -7 over root 5 times root 35. It's fine. And theta is going to be then the inverse cosine of that. Right. Keep an eye on me. I've been making lots of mistakes today on my other class. So if you see me missing something, tell me. Right, so -7 divided by a bracket, square root of 5 times square root of 35. 121.9 to the nearest whole number, which seems to be the theme, is 122 degrees. That's a kind of bread and butter question, isn't it? No frills, just plug and chug. You get an answer, makes sense, 122, right? It's bigger than 90. One of my other students, I was talking to them yesterday at the end of class, and I think I should mention it right now. What's the biggest angle between two vectors, u and v? What's the furthest apart they can be? Is it more than 90?
180?
180. Can you imagine a vector u going this way and the vector v parallel to it, but going in the totally different direction? wouldn't the angle here be 180 degrees? Agreed? What's the smallest angle that you could get between two vectors?
0.
0. And that would happen if you had vector u and vector v not only parallel, but parallel and traveling in the same direction. These two vectors are considered parallel because if you do the lines, right, they're parallel, right? They're pointing in different directions. Why, this is the last part of this, why can you not get an angle between two vectors bigger than 180?
Because then you can just start measuring from the other side and it just gets smaller again.
Yes. So can you imagine, I think the last one I did, if you looked at the end, imagine that angle was 300. Wouldn't we call the angle between them 60? Right. The cosine guy takes care of that. You don't need to worry about which quadrant the angle is in. Am I accidentally going to get an angle that's more than 180 and I have to fix it or anything like that? None of that's going to happen. The cosine will tell you exactly what the answer is without any changes. So if it says 112, it will be 112. Are we good? Okay. Let's see. If you are given two vectors, u and v, and you are given three choices. First one is that they could be orthogonal. The second choice is they could be parallel. And the third choice isn't very interesting. It is neither of those two things. Okay. If the two vectors are orthogonal, isn't that a fancy word for right angled, right, 90 degrees, then theta will be 90 degrees, agreed? And in this case, you would know that because the dot product would be 0. What angle will you get? And I'm going to rephrase that. What angles will you get if they are parallel?
Zero
Okay.
and 180.
0 degrees are both going in the same direction, but 180 is actually, you know, those two vectors that I'm drawing here are parallel, aren't they? They're just pointing in different directions. Parallel doesn't include direction. Parallel just means the two lines are like railway tracks, right? Technically, in my opinion. Right, and neither is the rest. So there's a question 15 where that's going to be asked. So it's really just, they're getting you to use this formula here to find the angle. But instead of writing down the angles 120 degrees, or which case you pick neither, or 0 degrees and you pick the middle one, they're going to ask you just to check off one of these three boxes. But it's essentially the same question. Find the angle between two vectors, but don't write down what the size of the angle is. Pick one of these three. And that's what 15 is like. We did one yesterday like that. Did that one. Good. Right, I think I'm just doing a quick scan because I think there was one more I wanted to do and I can't find it now, of course. Right. I had letters in it. Oh, I think I did it. No, I didn't. I take it back. I found it. There's a question 3. And it's not even asking you to find the angle between two vectors A and B, just to find out what their dot product is. And A is P, negative P, and 8P. And vector B,
Yesterday.
I did do it. Okay, then I don't need to do that again. Next thing we're going to look at is still dot products, but it's the angles of a triangle. So let me find one. At least I can tell you what the question looks like. I'm scrolling by this like I knew what I'm doing. I know it's here somewhere. I know it's here. Ah, there we go. This is like question 8. And you're being asked to find here to decide whether the 3 points of a triangle are right angled. And your answer is going to be yes or no. P has coordinates -1, -2, 0. Q has coordinates 0, 1, and -2. And R is 4, -1, -3. Now, if you imagine that this is P, this is Q, and somewhere down here, this is R. We would like to know, is this a right angled or not, right? We're given the coordinates of P, Q, and R. But to tell whether this angle at P is right angled or not, would you agree that we need to find these two vectors, PQ and PR? You agree? Now, if I can find those vectors, can't I then do the dot product and figure out whether or not they are right angled? So here goes. If you want to find the vector joining P to Q, can you remember yesterday it was, I called it 2 take away 1, right? 2 take away 1, 2 take away 1. Just remind you what I'm getting at here. Cover this up. Q take away P. So it's 0, take away -1. Second guy, take away the first, right? 2, take away 1. And so the vector PQ is 0 take away, that's 1, 1 take away, that is 3, and -2. Double check that. 1, 3, -2. Put a little bubble around it. Now I'm going to find P to R. Second takeaway first. So 4 take away -1 is 5. -1 take away that guy is 1. -3 take away that guy is -3. And we get that guy. And now I'm going to find the dot product. Now, before I actually do this calculation, let's pretend we knew what was going to happen. I did the dot product and the answer is 12. Is this a right angled triangle? No. I do it and it's -12. Still no. I do it and it's 0. Is it right angled now? If the dot product is 0, will the angle be 90 degrees? Yes. So 1 times 5, add 3 times 1, add -2, -3. In this case, I get 5, add 3, add 6. I get 14. And so it is not right angled. And you have only 2 choices here.
But don't we have to try all 3? Because it doesn't
Oh,
give us a specific point. It just
you
wants
are
to know if the
correct.
triangle is right angle.
Yes, you are quite right. all I've proved right now is that that angle is not right angled. I know it doesn't look it in my picture, but couldn't this one and this one be right angled? So if I wanted to test this one, wouldn't I find QP and QR and do the dot product? And then I want to test this one and do RQ and RP. I was making an assumption here, which I don't think I should have made. And I was making the assumption that because of the order they gave me them, that the right angle, if it was going to exist, would be at P. But there's no reason to assume that. They didn't tell me it was at P, right? So I really should check all three. I don't know. I'm not going to do the other two, but it could well be right angled, right? Could be right angled up there, right? That's possible. So next fella to do is a guy called direction cosines. This picture is ugly, and I'm not sure how good it is, but the picture in the textbook is just as ugly, so it's not like I did any better. Imagine a vector in 3D space, right? Like this pen. Coming out of the paper, right? That's V. Now, if I do at least the X and the Y axis, which I think I can get away with, can you see that this pen makes an angle with the X axis? That's called alpha. And the cosine of that angle, alpha, is the X coordinate of the vector divided by the magnitude of the vector. Now, would you also agree that this pen makes a different angle with the Y axis? And that's called beta. And the cosine of beta is the Y coordinate of the vector V divided by the magnitude of vector V. And then if you imagine this pen being the Z axis, can you see that my vector makes an angle with the Z axis? And not surprisingly, it's called gamma. And the cosine of that angle, gamma, is the Z coordinates over V. These three guys are called the direction cosines of the vector V. Did that help having pens rather than this, right? Don't know how well it helped, but it gives you an idea. Now, before we get too caught up on it, the vector V is just called X, Y, Z, right? So it could be any vector V that you could possibly want. If you take the cosine of alpha and calculate it, the cosine of beta and you calculate it, and the cosine of gamma and you calculate it, that's these three guys, do you know that you get the unit vector of V? Does that make sense? Why that might be the case? Look at the formula for this fella. It's X over the magnitude, comma, Y over the magnitude for beta, and for gamma, it's the Z coordinate over the magnitude. If you pull this out, isn't that this fella? X, Y, Z. Wait a minute. Isn't that how we find unit vectors? So a unit vector is really a vector made up of direction cosines. And a couple of questions you're going to be asked using these. You're going to be asked to find cosine alpha, cosine beta, and cosine gamma. And you're also very often going to be asked what angle alpha, beta, and gamma is. Let me tell you a property that's not true, just in case you think it might be. If you find the angle alpha, beta, and gamma and add them up, they do not add up to 180. Because those three do not make a triangle. Those three are totally independent of each other. They could be any number between, I guess, 0 and 180 in each of the three cases, right? Depends on where V happens to be point. So there is no direct connection between alpha, beta, and gamma, right? They don't always add up to 90 or 180 or 360 or any other number. They add up to whatever they decide to add up to, right? And in different situations, they add up to quite different results. So let me give you an example of calculating direction cosines. And this one is question 9, or at least like question 9. 3, 1, 2. That'll be my version. Well, so what do you do? Well, basically that's your X, your Y, and your Z. It's a good idea to find this fella. 3 squared add 1 squared add 2 squared. You get square root of 14. So now I can answer the direction cosines. The cosine of alpha is X of the magnitude of V. So it's 3 over root 14. Cosine of beta is the Y over that guy, which is 1 over root 14. And the cosine of gamma is Z over this fella, which is 2 over root 14. And since I'm a purist, let's rationalize the denominator. Because the 2 and the 14 will cancel. So if you were being asked to find the direction cosines, they want you to find these three things. You might write the answer down in vector format, or you might not as well. Now, if I write it down that way, haven't I also written down the unit vector for V? Can you check that? But it is true. This is the unit vector of this vector V. Now, second piece is quite common. Not only do they want to get these, they want to know the size of these angles. I'll just do one. Okay, there's the direction cosine for alpha. Shouldn't take much to figure out how am I going to get alpha.
Inverse cosine.
And I believe they're sticking to the nearest whole number rule. Yep. Okay, so here goes. Inverse cosine of 3 times the square root of 14 divided by 14. And I get about 37 degrees if you round it up. Do you want to see beta and gamma? Are you quite comfortable that they would be very similar looking calculations? You want to see them or not?
I think we're good.
Very good, okay. So I'm about to lie here. Beta ends up being 51 degrees, gamma ends up being 3 degrees. If you add those together, can you see that they just add up to a random number? Now, that, who knows what that is, right? It might be 82 degrees, it might be 40, but whatever it is, it won't be anything very spectacular. Here's the same question, but with a real kicker in the tail. The vector V is equal to C, 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 where C is a constant. And they want us to find the direction cosines and the angles. And you're going to think, well, how's that going to work? Well, let's just trust the math. Won't this be C squared plus C squared plus C squared, which is 3C squared. But can't you simplify that as root 3 times c? Are we cool with that? Now, the cosine of alpha will be c over root 3c, which ends up being that guy. I don't need to do any work for the other two. Would you agree that by symmetry, won't they be exactly the same answer? You agree it's the same numbers divided by the same numbers. So that's going to be that guy and that's going to be that guy. And now I can use, say, the first direction cosine, which is this fella. And I can find the size of angle alpha. And inverse cosine of the square root of 3 divided by 3. And it's about 55 degrees. Would you also agree that beta is 55 degrees and gamma is 55 degrees? So in this particular case, don't the three of them add up to, what, 165 degrees? Just a random number. Okay. Now you might think, why is this little thing called direction cosines? Can you imagine people in engineering talk about the x component of a vector, the y component of a vector, and the z component of a vector, right? And, well, isn't that what cosine alpha, cosine beta, and cosine gamma are doing? They're telling you in a unit vector format what those particular components are. So that might be a reason why you would want to know that. Okay, let's do a question that involves what you might do in an engineering class to do with forces. And I'm going to do it like it was a side-on world, but it's really not. Can you imagine that this is the point P and this is the point Q, but it's like sticking out, right? It's in 3D. And you are moving some object from here to here, and you are applying, it doesn't even be parallel to PQ, probably won't be, some force F to do that. So in a 3D world, you've got a big box, you've attached a rope to it, and you're pulling it up the hill from P to Q. How much work is done in doing that? That's essentially what we're going to be calculating here. And there is a formula for calculating the work done. And it's F dot product with D. Now F will be in the story. So let's say that the force is 1, 2, 4. So this is going to be 1, 2, 4. And D, well, D is the vector PQ. In this case here, I'll need to put in some points here. So let's suppose P had coordinates 1, 2, 1, and Q had coordinates 5, 7, 2. then the vector P to Q would be 5 take away 1, 7 take away 2, and 2 take away 1. It would be that vector. Okay, so the question would be, what is the work done in using a force 124 to move an object from position 121 to 572? Right, that's what it would look like. And there's your force function, and there's your movement. Right, so force vector, movement vector. And the dot product then, in this case, is 1 times 4, 2 times 5, and 4 times 1. 4 add 10, add 4, and the answer is 18. And they tell me somewhere if I look for it. And the units are Newton meters. Okay, or joules, for those who use joules. So it's relatively simple, isn't it, to find the work done? You get a force function, vector. You're moving it from one place to the other, which is what D is. The dot product of those two is your work done. So we can now calculate work done in 3 dimensions. All I need to know is a vector for the force F and a vector from the start to the finish position, and we are done. Could you get negative work? Could this answer be negative? I can imagine a combination of numbers here might be negative. You know, if you pull something downhill, are you really pulling it downhill, or it's going to go downhill on its own? In which case you're getting energy, not using it up. Just throwing that out there. Don't want to get too deep into it. That's what engineers have to do, not me. Are we comfortable about the process of how to calculate work done? We call that good, Dan? Okay. I'm getting pretty close to covering most of the stuff. I'm doing a quick scan through, see anything I've not covered. Looks like I've covered all that good stuff. Right, got find a little formula to take care of, that's fine. Do that later. That's a good question. Okay, we just got a couple of tidying up questions, like question 11 was a kind of tidy up question, it was a one-off. You're given in question 12 that the distance from a point P1 with the coordinates x1, y1, so this is really a 2D guy, to the line written in this format, ax plus by plus c equals 0, is given by this formula. It's the absolute value, that's just to make sure that it's positive, of ax1 plus by1 plus c divided by the square root of a squared plus b squared. And we're being asked to calculate the distance from the point with coordinates -1, 2 to the line 4x take away 3y plus 4 equals 0. Now I will be doing that question in a few moments. I just want to show you physically, geometrically what we're talking about. This is a 2D world question. I want you to imagine that I have a point up here called x1, y1. and I have a straight line, which is essentially this guy. Now, you know, if you rearrange this guy, can't you get it to say y equals 3/4 x plus 5 or something, right? So it's still a straight line. So I'll just call it y. We are asked to find the distance. Actually, they should have been a little bit more specific. They want the shortest distance to that line. Now, if I chose this point, would you agree that distance is not the same as this point, or this point, or this point, or actually this one up here either? If I wanted to find the shortest distance from this point to that line, this will calculate it for me. In fact, it's going to be that distance there. How do I know that that one's the shortest and not any of the other dots I put in? What's special about P, Q, and the line Y?
Perpendicular.
90 degrees.
Yes. And does that make sense that the shortest distance a point is to a line would be the distance that makes a right angle with the line? Geometrically, doesn't that kind of make sense? So that's kind of the theory behind that. The application is actually plug and chug. So who have we got? I guess I'll put little labels on them. You are A, you are B, and you are C. You're going to be X1 and you're going to be Y1. Okay. So it's the absolute value of 4 times -1 plus -3 times 2 plus C, which is 4. All over the square root of A squared, just 4 squared, plus -3 squared. Let's see what that gets us. -4, -6, and 4. And that's 16 add 9, which is 25, and the square root of 25 is 5. That's -6 on the top over 5, but the absolute value makes it 6/5. So if you wanted to know the distance from here to here, it's 6/5. You might think, what's that got to do with dot products? Well, they don't get into the details of it, but do you know that this formula gets created by using a dot product? They don't. I mean, I'm sure you can go online and actually see the proof of it. What we're doing is just using it. Okay, we're coming up for our last question, which is perfect timing. We should always keep the best till last, shouldn't we? This one is question 13. Find the angle between the diagonal of a cube and one of its edges. This is going to be fun. I am not being told how big the cube is, right? So it could be 1 unit long or 20 units long. So let's see if I can just imagine what that cube might look like. I'm kind of pleased with that. It does look like a cube, doesn't it? I'm quite pleased with my drawing today. Now, I don't know how big the cube is, so let's call this distance here C. So far, so good. Now, I need to know a diagonal of this cube. So a diagonal of a cube that I'm going to pick, and it's not going to come out very well on this picture by orientation, is this one here. Purple. So I'm going to take my diagonal as the one that's going from the origin to this point here, which I'll call P. Okay, now what is the coordinates of that point P, right? This cube that's kind of sticking out at the board there. He has an X value, he has a Y value, and he has a Z value. Right, here goes. Would you agree that you go C units this way? Then you go C units that way, and then you go C units up. So are you comfortable with P having coordinates C, 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 where C is whatever size the cube happens to be? And I'm picking the other one as the origin because that's an easy number, right? 0, 0, 0. So the diagonal is going to be the vector OP, which ends up being a very nice vector, C, C, and C. Are you okay then that the vector from the origin to P has component C, C, C? Now, I need to know the angle that it makes with one of the edges. And I could use this edge. I could use this edge. I could use that edge, right? Would you agree that there are 3 edges that I could have chosen? Do you want the one that goes straight up on the Z, the one that goes in the X direction, or the one that goes in the Y direction? Which one do you want me to use for the edge?
The X one.
Right. Now, if you look at this one here, right, this vector, would you agree that this vector is C, 0, 0? Are you happy about the C on the X, 0 on the Y, 0 on the Z, right? Because you're starting at the origin and you're going to this guy here. Okay, I want to know the angle between this vector and that vector. Right? I know I'm calling them E, P, and the edge. Well, can I just call U this vector, just to make my life easier, and V, I'll make the other vector, right? So I'm just calling them U and V now. Will be easy to do it. Right, the angle between these two vectors, dot product, C times C plus C times nothing plus C times 0. The dot product is C squared. Put a little bubble around that guy. Magnitude of U, the square root of C, C, and C squared. Oh, we've seen this guy before, root 3C. And the magnitude of V, C squared plus nothing, C. So I should be able to put this package together and find out what the angle between them is. It's the dot product divided by these two guys. C squared, square root of 3C times C. Wait a minute, isn't that C squared over root 3C squared? Isn't that 1 over root 3? Ah, don't we have just a number? A 1 over root 3. So to get the missing angle, it's the inverse cosine of that guy. I could make it prettier, but it's going to the calculator anyway. Inverse cosine of 1 divided by the square root of 3. And it's about 55 degrees. The angle between the diagonal of a cube and any one of its edges, at least from the center point, isn't that going to be 55 degrees? And it doesn't matter if the cube is 42 units or 4,000 units, it's still 55 degrees. Because it doesn't care how big the cube is. The angle is fixed. Okay, everyone, will you say hi? And I am getting so good at timing. 15 seconds. So say hi. I will hang about for any homework questions, and I'll see you all tomorrow, where we get to do a new topic in vectors called the cross product.
Thank you.
Okay. You're welcome. Bye-bye.
Are we gonna go over the scalar projection tomorrow too?
Did I put one of them in? I think I took it
Yes.
out. Okay. Remind me tomorrow, and the answer is yes. I forgot that one. What
Okay.
question number is it, just out of curiosity?
For me, it's number 20.
You are right. But it's a video example.
So we should just watch it.
Just watch the video.
Okay.
Basically, it's just a plug and chug formula.
Yeah, that's what it looked like.
Yeah. So just plug the numbers in that they give you and you'll be fine. So
Okay.
that's good. I'm glad I don't need to do that tomorrow. It would just distract the theme. What else we got? Any other questions? I
Just
guess,
watching.
yeah. I think vectors are probably generating fewer problems. Yes.
Can I see I guess a proof for the direction cosines? I'm struggling a bit to wrap my mind around why that formula works.
In the sense, works by what it tells, or how it tells you the angle.
Yeah, where it's
Okay.
cosine alpha is equal to
X over the absolute value. Okay.
yeah.
So let me see if I can put together a proof of that. I'll just try and prove it for the first one, right? So we've got the x-axis, and we have a vector v, which I'm going to draw kind of up here. And the angle that we're trying to find is the angle between the x-axis and the vector v. So far, so good?
Yeah.
Right, now, I'm going to call this axis here, and this particular guy, since it is the x-axis, I'm just going to use a single vector, 1, 0, 0. Would you agree that's 1 unit in the x-axis?
Yes.
So that's going to be my u vector. And my v vector is going to be called x, y, z, because it could be anything, right?
Mm-hmm.
Now, if I want to find the cosine of the angle between them, which in this case is alpha, it will be the dot product of u and v divided by the magnitude of u times the magnitude of v. Are we good so far?
Yeah. Okay.
So that's just theta, but we're calling it alpha because that's what they call it in direction cosines. That angle's called alpha. Right, now the dot product is basically 1 times x plus 0 times y plus 0 times z. The magnitude of that vector, can you trust me that it ends up being the square root of 1, which is 1?
Yeah.
And the magnitude of this vector, which I'm not going to calculate out, isn't the magnitude of this vector, just the magnitude of v.
Yeah.
Now, do you notice that the top is just x and the bottom is just him?
Yep.
And that's where it came from.
Okay, that makes sense.
And you can imagine beta and gamma being very similar. The only difference is beta will have a 1 here and these will be 0, and the gamma will have a 1 here and these will be 0.
Mm-hmm. Yep, that makes perfect sense. Thank you.
Okay, any other questions, guys? Then I'll call it a day. I'll see you tomorrow.
Have a good one.
Good day. Thank you.
You're welcome.